Alright, so today I'd like to show you that if you pick any positive integer p and any positive integer n, that p minus 1 will divide p to the n minus 1, or in other words, this number is divisible by this number evenly. So suppose I wanted to add up a series of numbers, and that series of numbers I'm going to call just x. X is going to be equal to 1 plus, let's say, p, our number p, plus p squared, plus p cubed, plus, and keep doing this until we get to p to the k, let's say, for some positive integer k. We just want to add these numbers up. Well, let's now look at what we can do here. Notice that because these are all powers of p, at least all these have a shared factor of p, which we can factor out. So x is equal to 1 plus p times, take one factor out, 1 plus p squared, plus all the way up to, and then this last one is going to have one less factor of p, so it's going to be p to the k minus 1. Now we notice something really interesting. Look at the similarity between this expression and this expression. They're almost the same. This is none other than x minus this last term, right? So that means it's going to be x minus p to the k. Alright, let's write this out. X is equal to 1 plus p times x minus p to the k is going to, if we multiply that out, it's going to be x equals 1 plus p times x minus p times k plus 1, right? Well, now let's combine the x terms. So if we move this over to this side, we'll get x minus px is equal to 1 minus p to the power k plus 1. Now we can do something else. We can factor out x on this side. So if we take x times 1 minus p, this is equal to 1 minus p to the power k plus 1. So long as p is not equal to 1, what we can do is divide by 1 minus p, so that x is equal to 1 minus p to the k plus 1 all over 1 minus p. Now you'll notice that if we have negative 1 times negative 1, or divided by negative 1, it's going to be equal to positive 1, right? So that we can multiply by negative 1 over negative 1, and we get that x is equal to p to the k plus 1 minus 1 all over p minus 1. Now what's so special about this? Well, I claim that x always has to be a natural number, a positive integer. For any positive integer p not 1, I guess, so any positive integer greater than or equal to 2, right? And for any k greater than 0, right? So 1, 2, 3, etc. I claim this has to be an integer, which means the number p minus 1 can always evenly divide into p to the k plus 1 minus 1. And why do I make that claim? Well, it's equal to x, but what is x also equal to? We define x as the sum of integers. Now, if x turned out to be like a fraction and it didn't divide evenly, that would contradict this expression, because this is an integer plus an integer plus an integer plus an integer all the way up to p to the k, so that there's no way that x can be anything but a positive integer. So that must imply that this is always an integer, which means p minus 1 divides p to the k plus 1, or just, if you like, n minus 1 for all p greater than or equal to 2 and for all positive n. Isn't that fascinating? Let's just pick a number. How about we set p equal to 5. All right, and we will set n equal to 3. So so we'll have 5 cubed minus 1 must be divisible by 4. I mean, this is a fairly large number. It's not immediately obvious just by looking at it that that's divisible by 4. This is 125 minus 1 is 124. Divided by 4 is going to be 31. So it works. Let's try another one. How about 8 cubed minus 1 is divisible by 7? Do you believe that? Well, 8 cubed is going to be equal to 512, so minus 1 is 511. Do you believe me that 511 is automatically divisible by 7 just because of this? Let's try it. 7 goes into 51 7 times. It's going to be 49. It's going to be 221, and it's going to be that 511 is exactly 7 times 73. And this is going to be true in general because this is a completely general thought process.